Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and sincere greetings to all. Welcome back, everyone. I hope members of the Zoom enjoy watching the virtual exhibition presented earlier. Okay, it is very interesting to see how the Ministry of Environment and Water and Nahrim successfully produced a drinking water from rainwater by implementing the microfiltration process. Okay, so here is the product. Okay. Okay. And without wasting any time, I think we can proceed our event with the final presentation session. Okay, do we have Dr. Siti Nazahiyah?
Yes.
Okay, good. Okay. So, ladies and gentlemen, our final presenter for the seminar, all the way from Johor, with her research title, Integrated Rainwater Harvesting and Groundwater System for Domestic Water Supply, please welcome Dr. Siti Nazahiyah Binti Rahmat. The screen is now yours.
All right. Thank you, moderator. Am I in a slideshow mode?
Yes.
Okay, thank you.
Right.
Assalamualaikum and a very good morning. Today, I would like to share my current research, which is basically on the integrated rainwater harvesting and groundwater system, or we call it as REGS, for domestic water supply. I'm Siti Nazahiyah Rahmat, and I'm from Faculty of Civil Engineering and Built Environment. This is the outline of my presentation. I will start with introduction, and then I'll share the pilot study that we have set up in our campus, utilizing rainwater and groundwater. And then I'll share some of the current research on this, the installation of the system, the methods and how it works. We have installed it at one of the schools in Parit Raja, Batu Pahat. And then I'll share some of the results. And last but not least, the conclusions drawn from the research. So as for introduction, although rainwater harvesting is gaining much interest, the promotion has been very limited due to several disadvantages. So this includes the seasonal variation, because in the country, the distribution of rainfall is not uniform. So that's why some of the months we receive a lot of rainwater, but some months with less rainwater. The second one is related cost. So this include the installation, the storage tank itself, and the accessories, right? And the last one is long return on investment. I think this matter has been discussed yesterday by Prof. Amir on the ROI. However, these problems can be solved by making the system with more than one purpose, such as the first one is dual water system with rainwater and groundwater. So this is what we are looking at now, right? And or maybe we can do research on hybrid system of rainwater and greywater, or rainwater and desalination. And the last one maybe can add values of flooding mitigation. So by installing this rainwater harvesting system, we can reduce the surface runoff as well as the flood. Okay, so the photo here shows this is our normal practice. We harvest rainwater for, and then we can use it straight away for daily users, or maybe we can harvest rainwater or store it for later use, or we could recharge to the groundwater system. But of course, we have to check the suitability because if the area with high groundwater table, the system is not suitable. All right. So the motivation of this study was to develop a domestic water supply system that integrates both rooftop rainwater harvesting and groundwater abstraction. And I think there's still limited research has been conducted on the integrated approach of conservation of water resources in the country. So this is a pilot study that we have in the campus. So I chose one of the buildings here to install the rainwater harvesting. It's a very simple design. And on the left-hand side is the groundwater system. The problem with the groundwater is that not the quantity, we have a lot of water, but the problem is the water quality. So that's why we provided very intense treatments that include aeration, we have post-aeration, and we also have a sedimentation tank here, and double filtration. And finally, we dilute it with rainwater in the final tank. All right. So for the rainwater harvesting system design, we have a collection system, which is a rooftop. So the conveyance system, we design for gutter, downpipes, and the conveyance pipes. And the last one is the storage system, which is the storage tank itself. So the design was fully referred to MASMA and also Nahrim Technical Guide number 2. All right. I think maybe some of you find it is a very very simple calculation. This is for catchment area. Since there is no wall or other structures on the rooftop, so I assume it is a single sloping roof freely exposed to wind. And I chose this equation, which include the surface area of the rooftop and the vertical area. And this is for gutter and downpipe sizing. So in Nahrim manual, they provided this table for gutter width and the diameter of downpipe based on the roof areas. And also for the gutter size, I referred to design chart 4.A1. And I think also they provide the design chart for downpipe sizing. Okay, so for those who are not familiar with the system, here we have, so here we have gutter, and then we have downpipe, and also we provide two first flush diverters. Okay, and then the water flows into the storage tank. So this is the first flush diverter. So how it works, this is a water flow from roof. Okay, and then the contaminated water is diverted into this chamber. So in this chamber, we have like a ball in here. And then when the ball rises, it seals off the chamber. And the rest of the water, the fresh water flows into the storage tank. So that is how first flush diverter works. All right. So based on the first flush volume that is suggested by MASMA in this manual, we can estimate or we can design the pipe of the first flush diverter, okay, based on the values suggested, the volume of volume required for water to be diverted. Okay. And the last one is the storage tank. So tank size, regardless of location, is 1 meter cube for roof area of 100 meters square. Okay, so for this study, I use a 1 meter cube of rainwater or storage tank. It is quite expensive because it is considered as a slim tank, because you don't have enough space to put all the black tanks here. So that's why I chose this slim tank. So it cost me, I think like almost 8,000 for this storage tank. Okay, and we can straight away, there's a outlet here, so we can straight away use the rainwater. But in the current study, I pumped it in the final storage tank because we still have a groundwater to pump in the tank as well. So previously, we observed the water level manually, but now we installed the online monitoring, so we can monitor the water level anytime and anywhere. Yeah. Okay, so this is the groundwater system, the tube well with 100 millimeters diameter, and these are all the treatment processes that I mentioned earlier. So we have an aeration process, and then we have post aeration. And this is the pump we use. The pump costs 400 to 500 each. Okay, so we have two pumps. This is for groundwater, and the other one is for rainwater tank. And this is the final storage tank where we store both rainwater and groundwater. So the next to the building is the concrete laboratory. So this is where the students do concrete testing. So they use the water here to clean their workspace. Okay, so this is a schematic diagram of the developed system, but I didn't include the treatment processes. I just want to show how it works. The orange line here is the rainwater flow from the storage tank to the final tank, and this is the groundwater flow to the final tank as well. So in the current study, rainwater was used in preference to groundwater because we want to fully utilize the rainwater. So the system was equipped with automatic devices. We put it in the final storage tank. The switching device used floats to automatically detect when sufficient rainwater was available. But when the rainwater levels were low, the device automatically changed back to groundwater. But we didn't leave the tank empty. There's still some amount of rainwater because we want to use that rainwater to dilute the groundwater. So dilution was also considered as one of the treatments in the current study. So this table shows the water demand, the rainfall observed, and also harvested rainwater and groundwater volume. From December, we observed from December 2018 to May 2019. Okay. The water demand is calculated based on the table that is given in MASMA. So basically the water is used for cleaning, and then rainfall observed range from 93.8 to 279 millimeters. This is the harvested rainwater, and also the groundwater. When there's the rainwater is not enough, we top up with the groundwater to meet the water demand. So overall, based on the performance of the system, I could say most of the days, because we did the analysis based on daily basis, the rainwater couldn't meet the water demand. Does have to be supported by the groundwater. Okay, so this is we upscale the system, and we install it at Madrasah Tafiz Darul Hikmah in Sri Gading, Batu Pahat. So this is the school. The location is surrounded by palm oil plantation and residential area. The average monthly rainfall ranged between 75 and 230 millimeters, and the area showed characteristic of soft soils which lead to high content of water. So this is us when we discuss on the installation of the system, and this is my students with some of the students at the madrasah. So the problem statements are: the average monthly bill for water usage in madrasah is 350 ringgit per month. The demand for water will continue to increase as more students will enroll in the future. So that is the main problem. And then they installed the rainwater harvesting system earlier, but it only covers a small portion of the roof. Okay, so they use it for non-potable use. They use for water ablution and for cleaning. So sometimes no storage due to prolonged dry days. So if we want to construct the groundwater, if we want to construct the tube well, the groundwater quality should be treated. Yes, it is located in the oil palm area. So in UTHM, we have an expert in groundwater exploration and tube well construction. So they use electrical for this study. They use electrical resistivity tomography to investigate the groundwater potential. We used a tube well of 4-inch diameter And then after the construction, we also did the pumping test analysis. So this is basically the system that we have in the madrasah. So if you can see, these two are the treated water. This is SAJ tank, Syarikat Air Johor. Okay, and for groundwater, it is extracted by using the submersible pump from the tube well, and we store it here. For rainwater, we have two tanks. The first tank is this one, and we also provide another extra storage or extra tank in case the first tank is full. So if you can see, the first tank is connected with these two pipes here, pipe line 1 and this one pipe line 2. So this pipe conveys or channels the rainwater. It covers the back area of the roof buildings, while for pipeline 1 here, it covers the area of the front building. Okay, and these are all the treatment processes. Basically, this is for groundwater. So the way it works actually similar to the one that we have in our campus. We want to utilize the rainwater, and if it's not enough, we top up with the groundwater. But in the worst case, we tap the from the treated water. Okay, and then so this one for the treatment process, the water from the first tank was flows through the FRP. We have fiber reinforced plastic, and then the water flows through the microfilters, and then we have membrane filter, and we store it in the final tank. And before we pump it to the user, the water flows to the UV filter. Okay, so this is the treatment again. The FRP tank contains silica-based catalytic media. So it was designed to remove iron and manganese in the water. And the 4 microfilters here was designed to separate microorganisms and suspended particles. And for the membrane filter, was installed to act as a barrier to separate contaminants from water. And then we have UV filter was designed to help in disinfecting bacteria. Then determination of water quality. So this is rainwater. So we collect the samples were collected before and after treatment. This is for rainwater. We collect it from harvested the tank, the storage tank, and the groundwater was collected directly from the borehole. And we did in situ tests using portable multi-parameter meter, and we use PET bottles to collect the samples. So these are the parameters that we tested. We did in situ test for pH, temperature, DO, and TDS. And we also brought the samples to the laboratory to test for turbidity and heavy metals. And now we are also looking at the anions and cations that may be in the groundwater. So basically, this is the results for water quality. We have physical and heavy metals parameters before and after treatment. So since groundwater, we don't have any standard to compare with for groundwater, so I use a recommended raw water quality standard. And after all the treatments, I could say that all the parameters met the recommended raw water quality standard, met the requirement of this standard. As for the conclusions, the integrated system of rainwater and groundwater was successfully designed and installed in order to bring the water quality of madrasah to an acceptable level before it can be consumed. And then treatment consisting of FRP, micro and membrane filters could remove the concentrations of selected parameters. Overall, this study provides a significant reference for sustainable water management, and this approach can be efficiently applied, especially for rural areas where there is no domestic water supply. So I think with that, end my presentation.
Okay, thank you, Dr. Siti. Now, Desmina would like to open for questions and answer session. Members of the Zoom, you are welcome to ask questions.
Dr. Siti,
Yes, yes.
I have a question regarding the first flush system. You say the water is diverted into a pipe. So how do you empty the diverted water in the pipe? In the pipe?
We do it manually. We have to open the valve. If I can share. Because for this system, we just use the manual, the first flush diverter. This one here. So we have to open this one, the valve here, and then the water, the pipe here will be emptied. So we have to do it after every storm events, after rainfall events, we have to do it manually.
Okay, thank you, Dr. Siti.
Okay, thank you very much, Norhana, for the question. Do we have any other question before we end the presentation session and continue with the closing ceremony? Okay.
Mana dah tidak tahu kan? Kan?
Okay.
Allah.
And are there any other questions from the Zoom member?
Any question? Apa nama dia?
Wan Azhar Sulaiman.
Ya. Siti Rahmat. Hello? 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 Assalamualaikum.
Okay.
Siti Rahmat. Di madrasah yang you buat sistem tu, combined system tu, berapa total cost dia? Kalau nak apply tu, kalau rural area, kalau tak menguntungkan, jadi susah juga nak apply pada saya lah. So how much cost yang you buat research?
Cost tu sebab termasuk dengan groundwater lah kan. Sebab ada tank tu yang memang dah ada. I mean ustaz tu memang dia sendiri nak harvest rainwater. So cost tu hari tu lebih kurang sebab dia projek ni separuh-separuh lah macam tu kan. So lebih kurang and around 20,000. Because kita gunakan pun tank yang sedia ada satu lagi yang jenis tank hitam tu dia murah sikit lah berbanding dengan yang kita pakai.
Polytank.
Betul.
Terima kasih.
Okay, thank you, Mr. Wan Azhar. Okay, I think it looks like we have come to an end. I hope members of the Zoom have found this presentation useful. Thank you so much, Dr. Siti, for the insightful presentation and discussion.
You're welcome.
We can see how Dr. Siti and team benefiting the rainwater by developing the rainwater harvesting system impressively and assist the madrasah in saving the cost for monthly bill for water usage there. A very noble effort from Dr. Siti and team. Congratulations, Dr. Siti.
Thank you.
Yeah. Okay, so before we end the presentation and proceed with the closing ceremony, on behalf of all the community members of VISRAWET 2020, I would like to record my heartfelt thanks once again to all speakers and all the participants for your time and effort. Okay. Signing off from my desk. With that, I pass the screen to our MC, Wan Raihan. Assalamualaikum.